Hello, Tom from Every Step Physics, EveryStepCalculus.com. Spring is in a vertical position with a mass attached to the end of it, and that mass causes a 22 centimeter stretch of that spring because of gravity. And so it's asking to find the period of it, so let's show you how that's done in my programs, okay? Important thing to remember in springs, of course, is that the stretch, when you put the mass on the end, is different than amplitude. And amplitude is when you take it from equilibrium position and pull it down a little bit further and then let it go, and it goes up and down, up and down, up and down, positive and minus over and under the equilibrium point. And in space or in a vacuum, it would go for any amount of time, okay, doing that. So, and there is I've watched it on the space shuttle, how they do spring calculations and check Newton's law, etc. Pretty interesting. But anyways, we're going to do it in my programs physics. To get to my menu, you can purchase my programs at www.everystepphysics.com for $30, and you get 350 programs which I send to you. And you load that into your calculator, and you pass all your physics homework and tests, okay? You'll notice how worthless your physics book is and all the questions you might have. That's because professors and physics authors are all trying to act like they know more than everybody else, and they get into stuff to show everybody how smart they are. Well, that doesn't answer a lot of our simple questions that we are trying to question for our tests or homework. And we want just enough information to pass the class and get out of there, okay? Never to touch it again for most of us. Physics, to get to my menu, I'm already at springs. You'd scroll down to it if it wasn't there with the cursor here. But I'm going to so we're at spring calculations, and we're at vertical spring. We choose that, and then we choose what's given, which is mass and stretch. This tells us that when the mass is attached to the bottom of the string, it pulls it down by gravity a certain distance because you've attached that weight on there, and in this case it's 22 centimeters, okay, and that's called the equilibrium point. And if you pull it down further and then let it go, it'll oscillate between the equilibrium up and down, positive and minus, for any amount of time if you're in a vacuum. And there's calculations for all of that, okay? All in my programs here. So we're going to scroll down to mass and Y. Now notice why it's Y, because you have a vertical spring, which is any stretch would be in the Y axis, okay? If you're a horizontal spring, you're in the X axis, and so any stretch would be X. But in a vertical position, it's Y, okay? So let's scroll down to it. Mass. And there it is there, mass and Y, okay? Press enter. And we're going to enter the mass that's given. You have to press alpha before you enter anything in these entry lines here. Alpha 3 4 0. Press enter. And then we're given grams, so we have to convert that. I do that for you. We press 1 or choose 1 or scroll to it and mark this on your paper. And then we're asked for the stretch, okay? So we're going to alpha, enter that. Now alpha 22 and centimeters, number 2. Do the conversion. I show you what you've entered. You can change it if you want. Say it's okay. First we find the spring constant because of Hooke's law. Force equals the constant times the distance. Stretch And then because of algebra, we figure out what K is, and here's 15.161 Newton meters. That allows us to find the angular frequency, square root of K over M, and that becomes 6.6776. Because we found the angular frequency, we can find the period, 2 pi over omega, which is angular frequency, of course, and equals 0.94093 seconds. Now we can see the answers again as many times as you want, and then we press 2 and we're to a new problem. Pretty neat, huh? EveryStepPhysics.com. Go to my site, buy my programs, and pass your physics classes. Have a good one.